We want to find this definite integral from 1 to e to the power of 4 of 4 dt over t times 1 plus ln squared of t. All right, so that's a little bit interesting right here, right? Now, don't be fooled by this, right? When we say ln squared of t, right, it's the same thing as ln of t squared, okay? So let's now, the 4 we can always bring out, right? But, how are we going to solve this? And the key is, right, this looks like an inverse trig function here. Okay, so let's let u equal ln of t. Okay, and we know what the derivative is then, right? It's 1 over t dt, and that's good, right? Because we see the dt, we see the t on the denominator here as well. Okay, so really, what does this convert into, right? Let me bring out the 4, right? So we get what? We get 1 over 1 plus u squared du. Okay. So remember, you gotta be careful with here. I didn't let u equal 1 plus ln squared of t, right? So let's do that. If I let u equal 1 plus ln t squared, right? Then that's just going to bring out a whole other thing which we don't want to deal with, okay? Because then du, what does du equal, right? It's 2 ln of t times 1 over t, right? Which it's not going to work, right? Because we don't see that extra ln of t here, okay? So we don't want to do that, okay? But I was able to recognize that this is an inverse trig function here that we got, okay? So I just let u equal ln of t, so du is 1 over t dt, right? So here is where I let u equal, that's where I get my u squared, okay? What about the limits of integration here? Right. Well, I can't put 1 here in e to the power of 4, right? Because of this guy, right? So I got to plug in properly, right? If t is equal to 1, right, then u is equal to the ln of 1, which is 0. So that becomes a 0 down there. And if t is equal to e to the power of 4, then u is equal to ln of e power of 4, which is just power of 4, right? So this is what we end up with. Okay, and this, once again, this is the derivative of a trig function, right? The inverse tangent trig function, actually, right? So what do we get? We get 4, and this just ends up being tangent inverse of u, right? We're going to evaluate that from 0 to pi over 4. Okay. All right, so what do we get in this case? We get 4 times tangent inverse of power of 4 minus 4 times the tangent inverse of 0. Right? Tangent inverse of 0, well, that's just equal to 0, right? You got to be careful with this one, though, right? Because this is asking where does tangent equal pi over 4, right? Which in radians, we don't know, right? This, for example, this answer is not equal to 1. Okay, a lot of students will make that mistake, okay? So actually, the tangent inverse of pi over 4, right? Tangent inverse of pi over 4 is equal to, let me put this in my calculator here, right? It's about 0.66, okay? So it's not equal to 1, right? What do I mean by that is, if I ask you what is tangent inverse of 1, right? Well, that's equal to pi over 4, right? So this one's a little bit trickier here, right? And for all intents and purposes, we can leave this as the answer, okay? Now, if you want to give the decimal answer, right? Tangent inverse of pi over 4 is about 0.66. Multiply that by 4, we get something in the neighborhood of like 2.66 as a number, right? But otherwise, you can leave your answer like this.